Hello everyone, welcome back to Cambridge Guru once again. In the last video we talked about different types of number systems, and we also talked about one number system which was rational numbers. And in that rational number we learned about two types of rational numbers, one which is terminating and second was non-terminating, right? Now as you can see on the screen, that rational number we talked about two types. Type 1 was terminating and second was non-terminating but recurring. So this was non-terminating, recurring or repeating. Okay, and you can say the shortcut or the method to find out whether the given rational number will be recurring or non-recurring. So the trick is that whenever in the denominator of a rational number, let us say the given rational number is 2 upon 5, and we need to find out whether this is a repeating or non-repeating, right? So here we can say that since in the denominator, if the denominator is a multiple of only 2 or only 5 or both 2 and 5, right? So only a multiple of 2 or only a multiple of 5 or both 2 and 5, right? So if the denominator of the given rational number is either a multiple of 2 or a multiple of 5 or a multiple of both 2 and 5, then that rational number will be terminating rational numbers. For example, 2 upon 5, its decimal equivalent is 0.4, right? Or you can say second example could be 5 upon 8. This will be 0.625. Again, this is terminating, okay? Because in the denominator here, 8 can be written as 2 cube. This 8 can be written as 5 upon 2 cube, right? So here also the decimal denominator is a multiple of 2 only, right? So it will be a terminating decimal number or rational number, right? Or a combination of both 2 and 5. Now if any number is a multiple of 2 and 5, that means it is a multiple of 10. And whenever in the denominator we have 10, then simply you can put a point after the number of how many numbers, the number of zeros in the denominator will be, you count the number of zeros in the denominator. After those many, you can say, decimal places, you can put a point. Okay, so this was about finding out whether the given rational number is terminating or non-terminating, right? And the opposite of this, that if in the denominator there is not a multiple of 2 or 5, or we have another multiple of not multiple but another number in the denominator, for example 2 upon 3. So 2 upon 3 in the denominator we do not have 2 or 5 or both, then this is a non-terminating but repeating, and as you know that its decimal equivalent is 0.6666 up to infinite number of digits, right? If I take another example, let us say I write 1 upon 6. So as you can see here, we have a multiple of 2 here, but I said, you just notice here, I write only a multiple of 2 or only a multiple of 5 or only multiple of 2 and 5. The word only is important here. So here we have a multiple of 2 in the denominator, but this is not sufficient. Only it is not only 2, right? We have 3 also in the denominator. So its decimal equivalent will be recurring and non-terminating. Okay, so this was about finding out whether the given rational number is terminating or not. Now from the exam point of view, the type of questions that will be coming in your exam will be that one given recurring decimal is given to you, and you need to find out its rational equivalent, the fractional equivalent of the given recurring decimal. Okay, so that is our next topic, which is expressing a repeating decimal as a fraction. So here it says example number 1 that we need to write the recurring decimal 0.3 with a point over 3. So this simply indicates that this 3 is repeating. whenever a digit is repeating in any recurring decimal, we put a bar over it, or we put a simple point over that digit which is repeating in the number. Okay, so how we will find out its rational number, equivalent rational number, right? So the first step is that you assume the given recurring decimal, in this case which is 0.3 bar, as a variable x. Okay, second step is you rewrite this recurring decimal without the bar, meaning you just expand this 0.3 up to certain decimal places like this, at 0.3333 and so on. Okay, this is my second step. Now third step will be, this is very important, you count the number of digits which are repeating. In this case, we have only single digit which is repeating, right? We name this equation as equation number 1. Now, you will multiply this equation number 1 by those many multiples of 10, those many meaning the number of digits which are repeating. In this case, we have only a single digit which is repeating. So, we will multiply only a single multiple of 10 with this equation 1, or we will multiply equation number 1 by only a single multiple of 10 which is just 10. Okay, so on multiplying equation number 1 by 10, we get 10 times of x is equal to, now whenever we multiply any decimal number with 10 or 100, so that decimal will be shifted to those many number of zeros or places, not zero. So this point will be shifted towards right by single decimal place. So this will be 3.3333 and so on, right? So you can name this as equation number 2, right? Now what you need to do is, we need to subtract equation number 1 from equation number 2. This is my third step. Okay, so subtracting equation 1 from 2. In order to do so, let us rewrite these equations so that the subtraction becomes very clear. Okay, if I say that we are subtracting the above equation from below, so it becomes difficult to match the digits. So what I am doing is, I am just rewriting these equations 2 and 1 once again, but first I will write the bigger equation, bigger in the sense that the magnitude of equation number 2 on left hand side is bigger. So I will write the equation number 2 first. So 10x is equal to 3.3333 and so on, and this is equation number 1, which is x equal to 0.3333. Now as you have noticed here, right, that by multiplying this 10, I have matched both the equations. Matching both the equation means is that I am matching this 3.33 and 0.33. I am matching these two decimal numbers, right? So next step, as I said, is to subtract equation 1 from 2. So I put a negative sign on both the sides. The moment I subtract these two equations, I get the answer on left hand side as 9x is equal to, now as you can see here, that all these 3 gets cancelled with each other. How is it possible? Because we have matched the decimal numbers on right hand side. This decimal point is just above this decimal point. Okay, and there is only a single decimal place on left hand side. So this is called matching the decimal numbers. So all the 3's after decimal point gets cancelled out. So you just remain with a single 3 on right hand side. Okay, so you will get x as 3 over 9, which is nothing but 153. Okay, so this is the rational number whose decimal equivalent is 0.3 bar, right? Let us do, before doing some more questions, if you want to note down these steps to follow in order to convert the given recurring decimal into a rational number, right, you can follow this mind map. Okay. So it says converting repeating decimal to a fraction. As you can see, the first part is you need to define the decimal. So you set x as a repeating decimal, which is 0.3. Then express decimal explicitly, right? Write x as 0.333 like this. You multiply it by 10. Shift decimal by multiplying by 10, or in the bracket it says that we will multiply by 100 or 1000 depending upon the number of recurring digits. Okay. Then align the decimals, align the original and shifted decimals, and then subtract the original from the shifted equation. You will isolate and solve for x. Okay, so these are the steps that we follow while solving these type of questions. Okay, so let us do a couple of more questions like this. So example number 2 here says that write the recurring decimal for 1.15 as a fraction. Okay, so solution is, I will recommend that you just pause this video and try to solve this question by yourself. Okay, then you can again visit or just play the video after that. Alright, so first step is you define this x as 0.1. Now I am just skipping this first step. I'm just directly coming to the second step, which is expanding this recurring decimal without the bar. As you can see, only 5 is repeating. So I will write this as 0.15555 and so on. Okay, and name this equation as equation number 1. Now second step, we will see whether we will multiply by 10, 100 or 1000. Now here also you can see that only a single digit is repeating. So we will multiply equation number 1 by only a single multiple of 10, which is just 10. Okay, so after multiplying this equation by 10, I get 10x is equal to, the decimal point will be shifted one place towards right. So this is 1.5555 and so on. Okay, so this is equation number 2. Rewriting equation number 1 just below 10x in order to align the decimals. So I will say that this x is 0.15555 and so on. Okay. Now third step is subtracting equation 1 from equation number 2. So you will get 9x on left hand side. On right hand side, now this is a bit different as we did the last question, that here one digit after the decimal point is not matched. Rest other 5s are exactly matched to each other. So after subtracting, all these 5 will get cancelled out. Okay, except the 1.5 which is towards the right of this decimal. As you can see here, this won't get cancelled with this one. So no problem in this. We can subtract this 0.1 from 0.5. Okay, so simply the number now on right hand side is 1.5 minus 0.1, which is 1.4. Okay, so on right hand side you get 1.4. Okay, so x is now 1.4 over 9. So this x is, you have to remove a decimal from a fraction, because if we are dealing with a rational number or fraction, then there should not be any decimal either in the numerator or denominator. Okay, so we need to remove this decimal. So writing this as 14 by 90. Okay, you can leave your answer as 14 by 90 also, but I would recommend that whenever we are dealing with rational or fractions, we should leave the fraction in simplest form. Okay, so as you can see here, there is a common factor of 2 in numerator and denominator, so I can rewrite this x as 7 over 45. So this is your answer. Okay, as easy as it is. Let us do one more question. I hope you have matched your answer. If not, please follow the solution here. Example number 3 now is again a little bit different. I won't say difficult, but different from the first two. So you can see here that instead of single digit, we have now 2 digits which are repeating. Okay, so 2 digits are repeating, meaning is that the decimal equivalent of this will be 0.24, 24, 24 and so on. So like this, the digits are repeating. Okay. Now, name this as equation number 1. Second step was to find out the number of digits which are repeating. Here we have 2 digits which are repeating. So we will multiply this equation number 1 by 2 multiples of 10, which is 100. Okay, so we will multiply equation 1 by 100 this time because we have 2 digits which are repeating. So this is 100x is equal to, no need to mention each and every time that on multiplying equation 1 by 10, 100 or 1000. Okay, it is just for the sake of your understanding I am writing, or I have written in the example 1. So after multiplying this 100, decimal point will shift 2 places towards right. So I will write this as 24.242424 and so on. This is my equation number 2. Rewriting equation number 1 again below this. So this x was 0.24. Just match the or align the decimal point. This is very important. Okay. So this 0 will be below this 4, not below 2. Okay. So 0.24, 24, 24 and so on. Okay. Next step is to subtract these two. If I subtract these two, on left hand side I will get as 100 minus single x is 99. X is equal to, you can see that all these digits which are towards right of the decimal point are exactly matching with each other, so they will get cancelled out. Okay, so only number that is left on right hand side is 24, minus 0 is 24. So that means x is 24 over 99. But again, we can simplify this if there is a common factor. So we can see that 3 is a common factor here. So x is equal to 8 over 33. This is your answer. Okay. So these are the question, or you can do one more example. Let us say we need to find out the rational number for the given decimal number, which is x is equal to, let us say 1.24 this time, right? And 2 digits are repeating like this. Okay, 1.24. So here this is different from the previous one because in the previous one there was 0 here, but in this we have given 1 digit on the left hand side. Let us see how it will affect the decimal or the rational equivalent. So writing this x as 1.24, 24, 24 and so on. Again multiplying this by 100. So I will get 100x is equal to 124. This time that won't be 24.2424. That will be 124.24. Okay. And I think that is only, that will make the difference. Okay, this is my equation number 2. Again, rewriting this equation 1 below equation 2 as 1.24. Just stay focused on how to align the decimal. 1 should be below this 4. Okay, 24, 24, 24. This is my equation 1. On subtracting these two, I will get 99x is equal to, these 2 and 4 will get cancelled with each other. You will get 124 minus 1 as 123. And x is 123 over 99. As simple as it is. Right? So do not get confused, because some books may say that if there are more than digits which are repeating, or there is a digit which is on which there is no bar on it, okay, so they form multiple equations. So here we do not need to form multiple equations. Let us take another example, then the things will get more clear to you. That Suppose find out the rational equivalent of 2.032. Now in this case, let us skip this 0 also. Let us include one digit, which is 2.132, and in this 32 is only repeating. Okay, no problem in this. We will write this x as 2.132, 32, 32, and so on. Okay, multiplying this by 100, because and this is the difference that some books say that we will multiply this by, let us say, by 1000, then multiply again, they will form another equation by multiplying by 100, and then they will subtract. So it's a very complicated case, so we won't do such thing in this question. We'll follow the same procedure, right? Just remember to count the number of digits which are repeating. So here again 2 digits are repeating, so we'll multiply the equation by 100 only. Okay, so 100x is equal to decimal shift. After shifting the decimal, you will get 213.232323 and so on. Okay, 213.2323 and so on. And this is 2 point, again rewriting this as 2.132. So 2.1323232. We have matched the or aligned the decimals. Okay, there is no problem in this. After subtracting, as you can see, this 3 is below this 3. So all these 3's and 2's will get cancelled out. You will get 213.2 minus 2.1. In left hand side, you will get 99x. This is 211.1. Okay, so x in this case is 211.1 over 99. After removing this decimal, answer will be 2111 over 990. And I'm not simplifying this because it is very complicated. So you can leave your answer here. Okay, so no need to form multiple equations. Only 2 equations are sufficient to solve any recurring decimal type of questions. Okay.